You want to obtain a sample to estimate how much parents spend on their kids' birthday parties. Based on the previous study, you believe that the population standard deviation is approximately 76.58. So that's your sigma. You would like to be 98% confident that your estimate is within $2.95. So your error, that wiggle room, that give or take, that's your error. That's going to be 2.95. And then it says, how many parents do you have to sample? So when you're looking for a sample size and you know what the population standard deviation is and you're looking for the sample size for means, the formula is sigma squared times your z critical squared all over your error squared. So other than plugging this information into the formula, really the only other thing that we have to do is find our z critical. And our z critical is that cutoff point that we're looking for when we're making our confidence interval. Now, according to this problem, we want 98% of the data to fall within the interval in that center area. And if we split the remaining 100% between the two wings, each wing is going to contain 1%. So when I'm looking for my z critical and I'm looking to see how far out in terms of standard deviations I am from the mean, I'm going to use inverse norm and I'm going to put in 1% for my area. So I'm going to hit second vars, and then I'm going to choose inverse norm. I'm going to put in that my area is 0.01. Because this is standardized and we're looking for z's, not x's, I'm using 0 and 1. And then I'm going to push enter. And I'm going to get that my z critical on the left is negative 2.33. So this here, this z cutoff is negative 2.33. And this cutoff here is 2.33 positive. So when I put in my formula, my z critical is going to be 2.3z. So now I just have to plug everything in. So I plug in that my population standard deviation is 76.58. That needs to be squared. I'm going to multiply by my z critical, which is 2.33. I'm going to square it, and then I'm going to divide by my error squared, and the error, our wiggle room, we want it to be within 2.95. So down here I'm going to put 2.95 squared. And when I put all of that in on the calculator, I'm going to get 3658.46. And with sample size, you always want to round up to make sure that your sample size is big enough to get the results that you want. So we always round up to the next whole number, so our final answer would be 3659, which is given here.